Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see what pin wall rectangular section beam subjected to torsion. So for this, we had already seen the derivation in previous video. So in this video, we will see numerical based on this one. Okay. So numerical part 2. In previous video, we had seen part 1. So now part 2. So the question is determine the wrapping distribution in the doubly symmetrical. So here doubly symmetrical is there. Rectangular closed section beam means it's a symmetry about x-axis as well as y-axis also. That's why it's a doubly symmetrical rectangular closed section beam. Shown in figure. So here it is given. When subjected to a counterclockwise torque. Now here that given is the counterclockwise torque T. Okay. So now just in the question again it's a given. Here it's a 1, 2, 3, 4. Okay. So now and here it's a given. For this one 3 to 4. That is TA thickness. For this one, it's a TB. Means what? This also, it's a doubly symmetrical. Means this also having thickness TA, and this side 1 to 4 also having thickness TB. 1 to 2, that is S2. Shear load is acting. 2 to 3, so going towards 3 means S3 is acting. 3 to 4, 4 is acting, and 4 to 1, so S1 is acting. Means in which direction we are moving, that shear load is acting. Okay, so now next what we have to do, just in previous formula also we have to take the section from the center. So now here at this center of gravity where is there we assume, right? And after that just give an elemental area that as EOS. Okay, now and this length is given as we earlier in one numerical we had seen that length was given some R equals to 100 mm, right? That is here, that is B. Okay, and this is the, or just you can say the cross section of this side is B and this side is A. So what will be this part from here to here? It will be B by 2. This will be B by 2. In this, sorry, A by 2. This is because total is A, so A by 2. And here it will be B by 2. From here to here B by 2, right? And from here to here B by 2 up to this. Okay, so now we have to find what? Wrapping distribution. Okay, so this is figure what? Torsion of a rectangular section B. Okay, so now go for solution. Okay, from symmetry, the center of twist R coincides with the midpoint of the cross section and point of zero wrapping. So here you can see this is the center of this whole figure also, right? And here, so by this because of symmetry, both are coinciding, that center of twist also as well as the symmetry of that diagram. So there also the center will be the midpoint of the cross section. Okay, point of zero wrapping. So there wrapping will be 0, lies on the axis of symmetry at the midpoint of the side. So all the midpoints of the side, that is line. We therefore take the origin for S at the midpoint of side 1, 4. Okay, take origin here. So you can take anywhere. Then you have to, suppose you are taking in this one, then you have to draw like this triangle area, and this will be the US. So you can take from any side because it's a doubly symmetrical. So any side we can take, and then the other side also we can say that will be there because of symmetry, right? So now what we are doing, we are starting from 1 to 4, okay, and measure S in the positive counterclockwise sense. So means now in the counterclockwise you see here like this, in the counterclockwise we are, or anti-clockwise you can say, we are measuring. So that is positive, that already we had seen. Okay, assuming the shear modulus G to be constant. So this time we are assuming what? This G is constant. Okay, so now the wrapping distribution produced by a varying shear flow as defined for axes having their origin at the center of twist. So their origin at the center of twist that time, okay, is also applicable to the case of a constant shear flow that already we had seen. QS and Q, if at the center of twist is at the origin, then QS will be equals to Q in previous video we had seen. So after that, WS minus W naught, that's here is that wrapping, WS minus W naught equals to Q into 0 to S ds by GT minus AOS area of that whatever the triangle we have taken by A into Q close integral ds by GT. Okay, replacing Q. What was the Q? In that also we use T by 2A. Okay, so for replacing it, so WS minus W naught Q for this Q, T by 2A. Okay, or let's see here. So I'm just writing first. Ws minus W naught is equals to Q. Q as T by 2A. I'm just replacing. Okay. Then close integral 0 to S ds by gt. Okay. Minus AOS by A into Q. So again Q, what? T by, okay, S by A into T by 2A, close integral of ds by gt. Okay, this is there. So now what we have to do? Take T common. Okay, so after taking T common, what we will get? Ws minus W naught or T by 2A common is equals to T by 2A common. Okay, then what is left here? That close integral of integral of ds by gt. Okay, minus AOS by A into close integral of ds by gt. Okay, now take close integral of ds by gt also, that we can take as common. Okay, so because ds by gt, just here the one difference is there, 0 to s, and this is for close integral, right? That's why we cannot take common. So this, now just see here, this one delta is ds by gt. So for this term what we are getting, this writing as delta. Okay, so this will be delta OS by delta minus AOS by A, this term here, where delta is what? ds by gt, and delta OS is what? ds by gt. So with this term, the delta is not there, so that with this term we have to take delta common, so that's why delta is in denominator. Okay, or wait, let me simplify further, then it will be more clear. Right, so let's see what we are doing. Okay, so T delta, what is delta? gs by dt, take that also common. So after taking ws minus W naught is equals to T by 2A. Now I am taking common what? From here, this ds by gt. Right, so take common, okay, this ds by gt. Okay, that for close one. Right, so this we are taking common. Then what is left here? This 0 to s, okay, ds by gt divided by, don't cancel this because here 0 to s and this is for close integral, both are not same, right? So this is for, because here not this with this term, that is not there, so means you have to divide 0 to s. Okay, and then for, this is for close integral ds by gt. Okay, and here this already we have taken common, so simply minus AOS by A. Now what we are doing, we are just this bigger one, so just for that we are just keeping the small one. So let's, this equals to delta, and for this we are, for this one we are writing delta, and 0 to s, so this is our delta OS, and this term is our what? Delta. Okay, so now substitute here. So after that what we will get? ws minus W naught is equals to T by 2A. This is what? Our delta. So delta. Okay, then this is what? Delta OS. So delta OS by delta minus AOS by A. Right, that is here. So just, okay, so where just we assume this as a small quantity, that delta OS, but that is not the simplifying. This is the bigger one, just to write in simplified way. That also you have to write where delta is close integral of ds by dt and delta OS. Okay, so this is for overall close, but now this is for 0 to s, so delta OS equals to 0 to s ds by gt. Okay, so now in equation 1, from this equation, what? There, put W naught equals to 0, right? Then what we will get? Delta equals to 2 into B by TB plus A by TA, that already we had seen this derivation, and A equals to AB, right? So from 0 to 1, that S1 should be less than, greater than 0 and less than B by 2. So after substituting, that delta OS is what? Just see here, delta OS is 0 to S ds by dt. So substitute ds by dt, this after substituting ds1 by tb, ds integration is, because tb is constant, so ds integration s1 by tb. So what we got, delta os equals to s1 by tb. Similarly, aos will be equals to as1 by 4. Okay, so this we will substitute in that equation. Note that from DOS and AOS are positive. Okay, so substitution for DOS and AOS from equation 2 in equation 1. So now substitute these, the delta. Okay, this in equation, this one, that we have delta OS and AOS value. Let's substitute there. Right, so after substituting, what we will get? Let's say 2 in 1. So that wrapping distribution in the wall 0 to 1, that is W01 is linear. So W1 is equals to what? T by 2ABG. T by 2A, because A is AB. Let's see here. A is AB. Delta is this value. So substituting all the values here. So T into delta is what? T 2 into B by TB plus A by TB. Right? And then by 2, and AB is what? That is AB. So after substituting this here, so this AB is for A, G, and this is for delta. So T by 2 A G into delta. Up to this it's clear. Now next, what is the term? Next, here, delta OS by delta and AOS by A. So delta OS, what we got? Here, delta OS is S1 by TB and AOS as AS1 by 4. Right, so just substitute. So after substituting here, this we will get. Right, just multiply and expand, take LCM. Okay, or simply you can take AB get cancelled. Right, so here this will be 1 by 8. Take 1 by 8 common. So now this becomes here 1 by 8. Right, because these two will get cancelled. So after taking 1 by 8 common, here this will be 1, and here this becomes 2b TB. This one. Now take the LCM. Simplify. So after taking LCM, what happened? 2b by TB minus b by TB minus a by TB. So this here, and divided by this one. Right. So this term all is there. So after simplifying, what you will get? 2b by TB minus b by TB. So this will give b by TB minus a by TB. Right. Whole divided by b by TB plus a by TB. Right. This term. Okay. And then this term into T by 8 ABG into B by TB plus A by TB. Right. So this B by TB, right? This B by TB, this whole term will get cancelled. Right. So after simplifying, this B by TB minus A by TB into this will left. So B by TB minus A by TB into T by 8 ABG. So this is your W1. Okay, so now we got W1. Okay, the remainder of the wrapping distribution may be deduced from symmetry and the fact that the wrapping must be 0 at the point where the axis of symmetry and the wall of the cross section intersect. So means where the axis of symmetry is there and where the wall of the cross section intersect, this we have to assume what? Wrapping is 0. Hence, the W2 will be equals to minus 1. Why? Because W1 plus W2 should be equals to 0. So W2 equals to minus W. Similarly, W3 plus W4 equals to 0. So W3 equals to, or W4 equals to minus W3, and W1 plus W3, that also will be same. So from here we can conclude W2 minus equals to minus W1, that is equals to minus W3, and that is equals to W4. So all W2 and W4 in positive way and W and W3 in negative way, that value will be equal given the distribution shown in figure 2. Yeah. Okay. So this one, right? The wrapping distribution. Note that the wrapping distribution takes the form shown in figure 2 as long as T is positive and B by T, B is greater than A by TB. So from here also you can say B by TB, if it's a greater, then only this value will be positive and T also should be positive. If B by TB is less than A by TB, means this value is negative. After that, if T is positive, then also the W1 will be negative. So T should be positive and B by TB TB should be greater than A by TA, then only the W1 value will be positive. Okay, if either of these, any one, okay, so condition is reversed, W1 and W3 becomes negative and W and W4 positive. So any one will reverse means what? Whatever the negative is there, that becomes positive. So that time W2 becomes minus W2 and minus W1 becomes W1 and minus W3 becomes plus W3 and W4 becomes minus W4. So if B by this one, B by 2 is greater than BA by TB and T is also positive. If anyone will change, if T will becomes negative, then what happens? Minus T into whole thing, negative. If B by TB becomes less than A by TB, then also this value will be negative. So these two conditions if satisfied, then only W1 remains. W1 will be positive, W4 will be positive, W2 and W3 will be negative. But any one will change, that get reverse, means either T becomes negative or B by TB, anyone, either T or B. B by TB is less than A by TB, that time just opposite will be there, means that time W1 will be negative and W4 will be negative, W2 and W3 will be positive. Okay. In the case when B by TB equals to A by TB, the wrapping is 0. Why? So B by TB is equals to, so this term will get cancelled, that is 0. So 0 into this whole thing will be 0, means W1 equals to 0, hence we can say wrapping is 0. Wrapping is 0 at all point in the cross section. Suppose now that the origin for S is chosen arbitrarily at say point 1. Now what we are doing here at a point 1, we can just write here at point 1. Okay. Then from the figure 3, so just see from figure 3 here, right? So we have taken origin as point 1. So this is not necessary where you have to take the origin. You can take origin anywhere. If you wish to, you can take origin here also. Then your figure should be like this. Okay. Then this should be your AOS. Right. So in starting just in earlier problems also we assumed origin at 1. So in this case also we are assuming at 1 only. Then from figure 3, DOS in the wall 1, 2 is S1 by TA. So DOS in wall 1, 2, 1, 2. Okay. That is equals to what? S1 by TA, and AOS is 1 by, because of the triangle S1. What is the area of triangle? Or half A, that length into, or half base into height. So half base and height is B by 2. So finally this becomes S1 B by 4, and both are positive because it's going to the counterclockwise, or you can say anti-clockwise. So just see here, counterclockwise. Okay. So now here also you can see that torsion is in counterclockwise. Okay. Substituting in equation 1 and setting W0 to 0. Substitute these things and put W0 equals to 0 in the equation 1. Then what we will have? W dash 1 2 equals to T delta by 2 ABG into S1 by delta TA minus S1 by 4. Just substituting the value whatever we got here. Right. For AOS and what? DOS. Where? Yeah. Right. So W1. Just substituting that value here. Okay. So that W dash 1 2 okay is equals to, so that W1 2 varies linearly from 0 to 1. Okay. So now W dash 2, for W dash 2 we are finding T by 2 ABG into, this is the delta value, 2 by B by TB plus A by TB. Okay, that time this positive, and 1 A by 2 into B by TB plus A by TB into TA minus 1 by 4. Again take 1 by 4 common, just in the same way we have to do, take 1 by 4 common, right? So here that will be 2, and take LCM, so A minus this whole thing, right? So after further simplifying, again what you can see, this plus term is here, that will get cancelled, and you are subtracting with this term, so that minus term will be there. In previous case what was there? Here minus term was there, so that's why this minus term got cancelled and we are getting plus. So this time we will get that minus. So here this plus will get cancelled and we will get minus. So A by TB minus B by TB at 2. So W dash 2 equals to T by 4AB into G into A by TA minus B by TB, or W dash 2 equals to, just take minus this one now, making this positive, taking minus common. So now B by TB becomes plus and this becomes minus. So B by TB minus A by TB with minus sign here. So that is for W dash 1 to 2. Similar way, we can find for W dash 2 to 3. T dash. So now just see 2 is there. Right. So for similarly S1 was there for 1 to 2, so S1. 2 to 3 is what? S2. So S2 by TB. So T delta by 2AG into 1 by delta, that you can substitute the value of delta also, 1 by A by TA plus S2 by TB minus 1 by 4B B plus S2. Right. So this is for W dash 2, 3. Okay. The wrapping distribution therefore varies linearly from a value what? Minus T into B by TB minus A by TA. Okay. By 4AG. So, or you can simply write T minus T by 4ABG, okay, into B by TB minus A by TA. From here to here, 2 to 0 at 3. Okay. The remaining distribution follows from symmetry, show that the complete distribution takes the form shown in figure 4. Now, so this will be like 1 to 4, then 1 to 2, then 2 to 3, then for 3 to 4, this will be there. So this is the complete wrapping distribution. Now, this is 4. So compare figure 4 and 2. So just see here. 2, how that was there. So this is just like, but now in that, what is there? The difference is that all are inside only. Right? Okay. So wrapping distribution is the same, but that in the later case, that is in this case, the complete distribution has been displaced axially. So this is along the inside, means that is displaced axially only. But in the previous case, that is in figure 2, that is not. The actual value of wrapping at the origin for S is found using that equation. Right. So what will be that? Just see here. Thus, W naught equals to 2 by 2 into ATA plus BTB. Okay. Into 0 to A integral of W dash 1 to TA ds1 plus 0 to B W dash 2 3 TB ds2. Now we have the W dash 1 2 value, W dash 2 3 value. Substitute in that one. So substituting in equation 7, right? W dash 1 2 and W dash 2 3 from equation 4 and 6 respectively, and evaluating. After substituting here, integrate it and simplify. Then what we will get? W naught equals to minus T by 8ABG into B by TB minus A by TB. That you can see that is similar to the previous one. Hence, subtracting this value from the values of W1 dash, that is equals to that what you do. W1 dash, just see what you are getting. Okay, this is W1, right? Yeah, right? That is same. So hence, that will give you a value of 0. Right? And W dash 2 equals to this value. Right? After subtracting, what we will get? W1 equals to T by 8ABG into B by TB minus A by TA. Then W2 will be minus T by 8ABG into B by TB minus A by TA. Okay. So this is the final wrapping distribution of W1 and W2, and it's all symmetry. So we can say for the other side also that will be same. So okay, let me recall once again this one. Okay, so in that question is given like what? Determine the wrapping distribution in doubly symmetrical rectangular form. So this is there. So now it's a doubly symmetrical, means it's symmetrical about x-axis as well as y-axis. So that's why it's doubly symmetrical. So we have chosen this one. So from 4 to 1, it's going towards 1, so S1. 1 to 2, moving towards 2, so that's why S2. 2 to 3, moving towards 3, so 3. 4 to 1, moving towards, 3 to 4, moving towards 4, so S4. That is there. This length is given. Right. For this we have to find. So we will start again from the same stress distribution formula. right? So that wrapping formula. So Ws minus W naught equals to Q into 0 to S ds by gt minus this derivation already we had seen in previous one. AOS by A into Q close integral ds by gt. Now replacing Q. So Ws minus W naught equals to T delta by 2A del OS by del minus AOS by A, where this del is what? That close integral of ds by gt, and this del OS is what? That 0 to S ds by gt. Okay, just we assume this one just for writing a smaller way, that is there, right? And substitute in equation when that W naught equals to 0 and delta equals to 2 into B by TB plus A by TB, and A equals to capital A equals to A into B. Let's substitute in that one, and so from here that delta OS as 0 to S ds1 by TB. So after integrating what we will get? S1 by TB, and AOS as AS1 by 4. Right? Just substitute this value, right? Delta OS, AOS, AA, delta and W naught in this equation, right? In equation 1. So this is 0, this will get removed. For this, all the values are there. After substituting, what we will get? We will get this value. Okay, so now what we can do? This AB cancel, 1 by 8, take 1 by 8 common, then here this will be 1, right? Then just take LCM, simplify, then what happens? Denominator, this term is there, so this term will get cancelled. Only the numerator part will be B by TB minus A by TB. So this is your W1. Okay, now similarly that we can say it's a axis of symmetry, so W2 will be equals to minus of W1 and minus W3 will be equals to W of 4. So all are equal but just opposite. Okay, so in the case when B by TB is equals to A by TB, so B by TB and A by TB, that means this equals to 0, means W1 equals to 0, hence wrapping is 0. Okay, so now and one more condition we have to think, if T is positive and B by TB is greater than A by TB, means this value will be what? Positive. So positive means positive into positive remains positive, but if any one will change, either T becomes minus T or B by TB becomes smaller than A by TB, any one case, then this W1 becomes minus W1, and then W2 is minus, so that will be plus. So whatever the is here, right, W2 is plus here, then in case of T is negative, W2 will be minus W, or B by TB is smaller than A by TB, then also W2 is negative. So here whatever the things are there in those two, any one will change, then that becomes opposite in sign. Okay, so now from figure that DOS as for wall 1 2 S1 by TA and DOS as this angle of that triangle half S into half height, right? Height is what? B by 2. So that is S1 by 4. Now substitute all the values. So this is this one. So this is figure what? 2. This is figure 3. From here only just see here. This one. Right? So this is S1. And what is the height? That is B by 2. So after just taking that value. So substituting equation 1 and setting W equals to 0, W naught equals to 0. So from there we got W dash 1 2 equals to T delta by 2AB G into S1 by del TA minus S1 by 4A after substituting. So this is the fourth equation. So that W12 varies linearly from 0 to 1. So 0 to 1, it's varying linearly. Now W dash 2 is T by 2ABG, putting delta value, this 2 into B by TB plus A by TB, right? Putting again this value, so A by 2 B by TB plus A by TA into TA minus 1 by 4. Take again 1 by 4 common. So here what will be there? 1. Again take LCM just like previous one. Simplify. You will get W dash 2 equals to T by 4ABG into A by TA minus B by TB. Or if you will further simplify, then that will just take this becomes positive, because in our previous equation B by TB was positive. So make this as positive, what? Take negative minus common. So W dash 2 is equals to minus TB minus T by 4AB G into B by TB minus, to just here. Or this W dash 2 because of the symmetry will be equals to what? W2. So we can say this is W2, that is coming minus W2. Okay, so now this is minus W2. So W1 is same thing without minus sign, W2 is minus sign. Okay, so now W dash 23 T delta 2ABGY into 1 by delta into A by TA plus S2 by TB minus 1 by 4B into B plus S2. So again further simplifying, what we got here, let's see, minus T into B by TB minus A by TB by 4AZ 2 to 3, that is linearly distribution of that rapid. The remaining distribution follows for third, fourth, and that is second quadrant, third quadrant, and fourth symmetry, so that the complete distribution take the form shown in figure 4 here. So from 1 to 2, this will be there. From 2 to 3, this from 3 it will be there. Then 3 to 4, 4 to 1. Okay. So after putting the value, WS will be what? W dash 1, 2 and W dash 2, 3 we found. So substitute in this equation. Right. After substituting and simplifying, what you will get? W naught equals to T by 8 minus T by 8 ABG into B by TB minus A by TA. Subtracting this value from the values of W dash 1 and W dash 2 equals to minus T into B by TB minus A by TA into by 4 ABG. We have W1 is equals to this one. So just see positive, and W2 same thing, negative. So W3, 4 also will be same. So W3 will be negative, W4 will be positive. Right? So that's why this is valid. Once if either T or TB by TB will change, then this will also change. That time W2 becomes minus W2 and minus W1 becomes W1. Okay, so this is for W1, W2. Similarly, W3 will be equals to what? Minus T by 8 ABG into B by TB minus A by TA. So this will be for W3. And W4 will be what? T by 8 ABG into B by TB minus A by TA. So this will be for W4. Clear? Like that for all the 4 sides, we can find the wrapping distribution. Okay. So again, for reference, you can just refer the TSG action book, or if you have any doubt, you can just comment on the video related to which equation you have doubt, or you can directly ask from me regarding your doubts. Okay.
Like, share and subscribe. Hit the bell icon for more updates.